Yeah. Okay. Hi. So let me tell you what is the importance of big data and data visualization. Actually, when I took the uh, form submission, then many of the members are fresher, and I got some requests that many of you have experienced. Many of you are coming want to come from Java background, or many members, many persons, many employers want to shift to big data uh, from SQL background or any web development background. So they have a wish, they have a target to shift his uh, domain from uh, their uh, present domain to big data. So I think it's a very good choice. It's a great choice, okay, because in upcoming future uh, there is a lot of opportunities for big data. Okay, so before go ahead, uh, we have to understand that the importance of the big data. Okay, and I'm requesting you to please. If you have any questions, if you have any doubts, um, so please do not hesitate, and please tell me, ask me any questions on the comment box. Okay, and you can ask me on group, Telegram group or WhatsApp group also. You can ask me on the chat box window. Okay, so and I have to be selective, but so I will answer all of your questions. Okay, and okay, so first of all, we have to understand the importance of big data and what is data visualization. So all we have all I mean all we have heard the term big data, right? And all we have heard the term, the word Hadoop. So you have heard about the word that Hadoop or big data. I'm talking about who are freshers. Uh, okay, so big data is a typically refers to any large quantity of raw data that can be collected, stored, and analyzed through various means that reveals patterns or trends relating to behaviors. Okay, particularly that of consumers, which can be used to maximize a business potential. Okay, so what is data visualization and why the data is big? We have to understand that actually, so collecting masses of data and finding a trend within the data allows the business to move much more quickly, smoothly, and efficiently. So we will collect the data, guys. We will collect the data, but collecting the data is not the solution, right? We have to visualize the data. We have to view. We have to create a view of the whole data. Okay. If the data uh, may have a structured form in structured format, in semi-structured format, or in unstructured format, but we have to transform that data into visualized form, right? So this is the global digital statistics, and you can check that the here in the picture you can realize from this picture that from 2014 to 16, huge amount of data has been generating, and now it is 2017. Okay, so you can realize, you can understand that we have we have to solve, or we have to transform a huge amount of data in with because collecting the big amount of data is not the solution. Okay, so why is big data important now? You can check, you can see that 43,000, approx 44,000 searches per second, every I mean searched in Google, 6,956 tweets in every seconds, 83,000 of videos viewed in every seconds. These are going in every seconds, right? So by 2020, at least one third of all data will exist in or pass through the cloud. So you, and businesses store 80% of all data. So you can understand that the opportunities and challenges both are uh, both is very huge, and the emergence of massive quantities of cell phone, tablets, sleep computers, as well as the growth of cloud computing, along with other data sources such as sensors data and IoT's data, have precipitated largest masses of data than anyone has ever seen, right? So according to figures given in the presentation, I mean I'm showing you, just last 2 years alone. Okay, so more data has been created than in all of history, right? Now you will get a uh, small idea from here that just what I was telling you, that big data means big opportunities. Okay, so opportunities means obviously job will be created. So obviously, we can understand that huge amount of data is generating day by day, and so big data means big opportunities of job creation will be happen. And this is the four dimensions of big data. I hope you have heard about these four terms: volume, variety, velocity, veracity, right? So I hope you can understand that what is volume. Volume means the scale of data, right? It's obviously it's scale of data. Suppose I'm picking an example from over here, there 40 zettabytes of data will be created by 2020, an increase of 300 limits from 2005. Okay. Variety means the different forms of data. Different forms of data. It may have structured form, in semi-structured, or may have unstructured format, right? Okay. And now it is velocity. What is where from the velocity is I mean velocity of the data is coming right now. It is the analysis of streaming data. Analysis of streaming data. That is, streaming means I hope you have heard about Apache Flume technology. Have you heard the term that Apache Flume? Apache Flume is a uh, uh, tool by which data stream can perform, and velocity means the analysis of streaming data over here. So suppose as per an example, modern cars have close to 100 sensors that monitor items such as fuel level and tire pressure. Okay, And the veracity means uncertainty of data. Suppose we cannot realize the data. Sorry, we cannot. Uh, we can. I mean, it is the data that we cannot recognize the data, right? We cannot recognize the data. That is the veracity. That means veracity refers to the data in doubt or uncertainty of data available due to data inconsistency and incompleteness. Okay, that is the veracity. And here it is. I hope you can understand that from this diagram that of these big data, four four V's means uh, volume, velocity, variety, veracity. Another two is visibility and value, right? Okay, okay, fine. So now I will tell I will tell you about the Hadoop 1.X. So I will tell you about the ecosystem of Hadoop ecosystem and advantages and features of HDFS. Okay, so please tell me that am I audible properly or not? Please, guys, please write on the comment box, on the live chat comment box, that am I audible properly, or you are getting any issue. My voice is repeating like before or not? Actually, okay, okay. Audible now, clear voice. Okay, Dinu Sweet, Bulbul Singh, Ankit Singh. Okay, Balachandar Kasilingam. Okay, everybody is saying it's fine, right? Okay, fine. So I will start the main topic from now. Okay, please attention over here. And yes, I am perfectly audible. Thank you, Sniva Das, for the confirmation. Actually, guys, I didn't have any experience about YouTube live broadcast. Okay, I didn't know anything about live broadcast setup. This is the OBS broadcast software. You can check over here. Okay, so here you have to set, you have to go to settings and many thing you have to set. So I didn't know anything about this. I'm sorry for my late, and late means I told you that I will take this session, but I know I am done very delay, so I apologize for that. Okay, so Hadoop ecosystem. What is Hadoop ecosystem? Okay, so Hadoop ecosystem is neither a programming language nor a service. It is a platform or framework which solves big data problems. We can consider it as a suite which encompasses a number of services inside it. So you can check that. You can see that here are many Hadoop components. Okay, top of HDFS, right? Here is this is the storage, Hadoop distributed file system. Okay, I will not discuss about yarn today because it will take much time to describe yarn. I will discuss yarn in any another day. Okay, this is the part of Hadoop 2.x. Obviously I will tell you about Hadoop 2.X architecture and workflow, but today I will not discuss anything about Yarn. I will discuss today about the Hadoop ecosystem of and the Hadoop 1.X, Hadoop 2.X, as I said, and Apache MapReduce. Okay. Okay, fine. So here you can check that every components are in top of HDFS, right? So here is, you can see that MapReduce, Hive. I hope you have heard these terms. Okay, who are new to big data and who are experienced. I am not talking about those persons that will be great, but I am talking about who are freshers, or because many of you are freshers, because when you submitted your form submission, I checked that many of you, I mean, more than 45% of you are you have written that I am a fresher. So okay, so I will tell you in very details, in more details, but uh, you have to ask me any questions. If you have any doubt, you can ask in live chat box or any group. I will answer all of your question. I will try to answer all of your questions. Okay, guys. So you can check that here is the MapReduce, here is a Hive, here you can check Pig, Mahout, HBase, Zookeeper. So what does these components? HDF is the Hadoop distributed file system, right? This is the storage device, the distributed file system. Okay. Yarn is a yet another resource negotiator, right? Resource manager, application master. Have you heard about these terms? I will tell you in details. It is the MapReduce. I hope you have heard this term, obviously. Who are from Java developers, they have heard this MapReduce terms. I think they obviously they know about this term MapReduce, Apache MapReduce. Spark is in-memory data processing. Okay, Apache Spark. This is very fast. Okay, and nowadays many companies are using Apache Spark as well as Apache Hadoop and Peak, Apache Peak, Apache Hive. These are the data processing services using query, SQL like query. Who are from SQL background, they will get many benefits, many preference when they will go through Apache Hive, Apache Peak. Okay. HBase is the NoSQL database. Okay, NoSQL means no SQL, right? Which is the, I hope you can understand what is NoSQL database. You have heard about the term vertically horizontally scalable or vertically scalable. Have you heard about this term? I will tell you in details about HBase. I will maybe, if you like this video, then I will discuss about HBase or Hive in any another day. Okay. Mount is machine learning. Nowadays, Mount not is not using very much. Okay, Spark MLlib is using very much, and as I am a Hadoop developer, as I am from data engineer, as I am from data engineer background, so uh, I I I have not any knowledge about machine learning or graphics about this. Okay, okay. Uh, for the Spark question, for the Apache Spark, there has four modules in Apache Spark. One is Spark SQL, that is SQL like, obviously Spark SQL. Second is Spark Streaming. Obviously Spark streaming, if you know Apache Flume, so you will get an idea of streaming. Okay, and another two is graphics and machine learning library. Okay, Apache Drill is a SQL on Hadoop. Zookeeper is managing cluster. Uzi is job scheduling. Okay, job scheduling means if you want to run a job, if you want to schedule a job, you can do that. You can do that by using Uzi. Okay, Flume and Scoop. Scoop is, suppose you want to import data from RDBMS to HDFS, or if you want to export the data. After importing the data, you have to aggregate the data, right? You have to aggregate using Apache Hive or Apache Pig or anything, Spark, anything. If you want, you can use MapReduce. After importing the data from RDBMS to HDFS using what? Using Apache Scoop. After the aggregation, you have to say export the data from HDFS to uh, any location. It may be any location. Okay, so uh, for that purpose you can use Apache Scoop. Okay, these are the solid, Lucene, Ambari. These are the searching, indexing, provision, monitoring. I will not go in details about this. So you can check over here that this structured data. Why we have written structured data here? Because RDBMS, we are importing the data from RDBMS to HDFS. So we will use which is Scoop. That is the structured data, and if your data is unstructured format or semi-structured format, you can uh, you can uh, use Apache Flume, and you can stream the data using Flume streaming. You can uh, put the data into HDFS, Hadoop Distributed File System. Okay, here you can check that. Okay, and obviously this you have to uh, remember this diagram that every components are in top of the HDFS. Okay. Before moving ahead in the HDFS, let me take you through some of ancient statistics related to HDFS. Okay. In 2010, Facebook claimed to have one of the largest HDFS clusters storing 21 petabytes of data. Okay. So what is petabytes? What is zettabyte? I hope if any of you have any confusion, let me just a second. Let me see. Okay, just a second. What is petabytes? What is zettabyte? Okay, see over here, 1000 kilobyte, and this is the 1000 to the power 2 MB is it is a megabyte, right? And after that gigabyte, and it comes terabyte, which is TB, right? And after it comes petabyte. After petabyte, it is exabyte. After exabyte, it is yottabyte, right? Fine. So this is the petabyte here. I hope you can understand that.
So in 2012, Facebook declared that they have the largest single HDFS cluster with more than 100 petabyte of data. Yahoo has more than 1 lakh CPU in over 40,000 servers running Hadoop, with its biggest Hadoop cluster running 4,500 nodes. All told, Yahoo stores 455 petabytes of data in HDFS. In fact, by 2013, most of the big names in the Fortune 50 started using Hadoop. Or now you can know this is 2017, and you already know about the uh, uh, job trends about Apache, Hadoop, and big data. Many of you was asking me. I got many questions from you that many of you group members ask me sometime that Bhaskar, tell me what is the salary structure for this big data domain. Oh, no issue, you can check over here. Just a second. Many of you ask me. I got these questions from many of group members that ask me that what is the okay. In India, uh, just a second. Big data is I think big data is only domain where you can show your any experience. Suppose you if you have if you have a knowledge about PHP, if you have a knowledge about Java, if you have a knowledge about .NET, if you have knowledge about uh, I mean any technology, you big data includes the technology uh, as an experienced. Okay, so I hope you can understand, and you can demand 90 to 100% hike if you have proper knowledge on big data, because it is a new technology. Try to understand. Okay, so it I am talking about India. So you can check over here the salary package. Okay, it looks like good, right? And if you if uh, I don't know here. Many of you, I got many questions like this, that what will be the database developer. 1 second. I hope you can understand that it's a good package you will get, obviously, because yes, data engineering. This is the field we are. Okay. So median is 8,07,287. So I hope you can understand that it is a good it's a proper figure. I hope, right? Okay. So let's come to this topic. Come back to this topic. Okay. So I will be talking about what is HDFS, advantage of HDFS, features of HDFS, right? So before talking about HDFS, let me tell you what is distributed file system. It's nothing but a distributed file system talks about managing data, files or folders across multiple computers or servers. In other words, DFS is a file system that allows us to store data over a multiple nodes or machines. Obviously, multiple nodes will be there. Okay, multiple nodes mean machines. Okay, and Hadoop offers commodity hardware. You can use your machine also. I mean, common hardware you can use. Okay, so basically it serves the same purpose as the file system which is available in your machine. Like for Windows, if you have NTFS, or for Mac, if you have, I mean, hierarchical file system. Okay, so what is HDFS? Hadoop distributed file system is a Java-based distributed file system. So that allows us to store large data across multiple nodes in a Hadoop cluster, right? So if you install Hadoop, you get HDFS as an underlying storage system for storing the data into the distributed environment, right? Now, what is the advantages of HDFS? Okay, you may have asked me. You may ask me that what is the advantages of HDFS? This is the distributed storage. Distributed storage is the when you access Hadoop distributed file system from any of the 10 machines in the Hadoop cluster. You can check over here that the data nodes are these are the data nodes. Okay, commodity hardware means common hardware means you can put a common machine over here. Okay, okay. Common machines mean my machine. I can put my machine over. Okay, so you will feel as a if you have logged into single large machine which has storage capacity of 10 TB, total storage of 10 machines. So what does it mean? It means that you can store a single large file of 10 TB which will be distributed over the 10 machines, 1 TB of each, right? Parallel processing, so it is not limited to the physical boundaries of each individual machine. And the distributed and parallel computation means, please check this image, guys. Here if we have to read 1 TB of data, so what we have to do, suppose one machine, and here 4 IO channel. Okay, so each channel 100 MB per second, it will take 43 minutes. But if we have 10 machines and where 4 with 4 IO channel, each channel of 100 MB per second, the same speed, it will take 4.3 minutes. So you can observe the difference over here, right? So because the data is divided across the machines, it allows us to take advantages of distributed and parallel computation. So let's understand the concept about. So you have, I hope you can understand the concept over here. I think you can ask me any question. Okay, Raju Bestha asked me that for Hadoop admin. I will tell you about this. Please let me uh, finish this topic. Okay, so I hope you can understand that this is the parallel computation over here. So time is less. Okay. Okay, so horizontal scalability means you can check whether the horizontal scalability here is the scale out and this is the vertical scaling. Okay, what will be the difference over here? Last, there are two types of scaling: vertical and horizontal. In vertical scaling, which is the scale up, and horizontal scaling means scale out. So you increase the hardware capacity of your system, right? In other words, you procedure more RAM or CPU and add it to your existing system to make it more robust and powerful. But there are challenges associated with vertically scaling and scaling up. Okay, please observe here. There is always a limit to which you can increase your hardware capacity. So you cannot keep on increasing the RAM or CPU of the machine, right? You cannot increase, right? Here in this situation, can you increase any RAM or CPU? No, in vertical scaling, you stop your machine first. You have to stop your machine first on this situation. Here, vertically scaling, you have to stop your machine first. After that, you can insert a RAM or CPU, right? So after you have increased your hardware capacity, you restart the machine, right? In this situation, I'm talking about vertically scale up, right? But in case of horizontal scale out, you add more nodes to the existing cluster instead of increasing the hardware capacity of individual machines, and most importantly, you can add more machines on the go without stopping the system. Here is the hardware scale out. You can uh, without stopping your machine, you can insert any number of RAM. I mean, you can add more machines. You can add more machines over here. You can add more machines over here. You can easily add, right? It is very easy to understand. I don't think that I need to repeat this. Okay. So HDFS tutorial. In this HDFS tutorial, I will talk about the features of HDFS. I will not go in very details here. I hope you can understand that cost is very less. Cost will be very less for this because these are the commodity hardwares. Okay. No, you may think that big data means big types of big amount of money have to invest. No, not like that. uh, you can use your you can add your common machines over here, no problem will be there. Okay, it has it is designed like this variety and volume of the data. I hope you can understand the reliability and obviously fault tolerance. I will tell you about the fault tolerance. It is very important term, and as well as for the interview also. Okay, I will I am describing this sessions uh, uh, Okay, so fault tolerance is when you store data on HDFS, it internally divides the given data into data blocks, right, and stores it in a distributed fashion across the Hadoop cluster. That means across the Hadoop cluster, these data blocks are stored it in a distributed fashion across the Hadoop cluster. The information regarding which data blocks is located on which of the data nodes is recorded in the metadata. You do not have to go think about very details, because I will tell you how the how the read write operation is happening for Hadoop 1.X architecture. But just try to feel the fault tolerance over here, because it can tolerate the fault, no problem. And no high output data locality. I will not go into much details. Okay, so it was the Hadoop ecosystem advantages, features. I hope you got some idea. I mean, from this. So now I will tell you about the HDFS architecture, Apache Hadoop HDFS architecture. Okay. So these topics that will be covered in this. I mean, 1 second. Okay. Yeah, so this is the HDFS architecture. I hope you have seen this image. So you know this, the Hadoop distributed file system is a block structured file system where each file is divided into blocks of predetermined size, right? So you have to predetermine, because if you are a Hadoop admin, okay, if you are a Hadoop admin, then you have to uh, I mean uh, the size is predetermined. The block size is predetermined by the Hadoop admin. So Maybe it may the block size may be 64 MB, or it may be 128 MB. Okay, it depends on the requirement. So these blocks are stored across a cluster of one or several machines, right? So Apache Hadoop HDFS architecture follows a master slave architecture. Try to understand this. This is a very important topic. Master slave architecture. Who is master and who is slave over here? Name node. This is the name node, and these are the data nodes. So data nodes are the this total data nodes is called Hadoop distributed file system. Okay, here in every rack data nodes are there, and in each data nodes uh, many blocks are there. So the total data nodes are the slaves, and here it is the name node is the master. Name node will decide the where the data will store, in which block the data will store, right? Okay, that's why it is the master slave architecture, where a cluster comprises of a single name node, master node, and all the other nodes, data nodes, which is the slave nodes, which I have told you. Okay, HDFS can be deployed on a broad spectrum of machine that support Java, right? Okay, because Hadoop is a framework of Java's framework. So who are from Java background, they can learn comparable to little faster little faster than the others domain, but this is not mandatory that you have to, I mean, you have uh, knowledge, you will have to you will, I mean, this is not mandatory that I mean, uh, Java knowledge, the knowledge of Java is not mandatory over here. Okay, just I am saying. Okay, so because okay, so though one can run several data nodes on a single machine, but in the practical world these data nodes are spread across various machines, obviously. So uh, here you can check that if a client, okay, want to read data from data nodes. This is the data node 1. Suppose this is the data node 1. This is the data node 2. Okay. Please try to see my the mouse pointer, that you can understand that this is the data node 1. This is the data node 2. Data node 3. Okay. Data node 4. Data node 5. And these small squares are the blocks. Okay. Okay. So client want to read the data. Suppose client means, who is client? Suppose you are the client. Assume that. Okay. You are the client. You want to read data. You want to, suppose you have some data on data nodes. Data nodes mean HDFS. Data nodes mean HDFS. Okay. HDFS means if you have used Cloudera. Okay. So you have transferred, I hope you have transferred files from local file system to HDFS using put command, using copy from local command, right? So this is the thing, that you want to read the read your data from data nodes, that means the HDFS. Okay, so this is the name node. What does name node, I mean, on that time, what name node will I mean, what name node will do. So name node is the master node in the Apache Hadoop HDFS architecture that maintains and manages the blocks present on the data nodes, right? Name node is a very highly available server that manages the file system namespace and controls across to files by clients. Okay, okay. So try to understand that by the metadata information, I will tell you where the metadata information is stored. Okay, but by the metadata information of what? Metadata information, name, replicas, what is this, you can think that what is the we have written that high info data, right. So what is this? This is nothing but the information about the data, particular the data, where the data is um, where the data is in which location the data is present, in which location of data nodes the data is present. These informations name node takes from the metadata and reads the data from that data node. Okay, and the replication means you I will tell you about the replication, because when you will write the data on HDFS, suppose you have transferred the data into HDFS, right? You have transferred the data into HDFS from the local file system, right? So what happens actually, if the replication factor is 3, okay, if the replication factor is 3, it then the others, the same replica of your data will be stored into another data nodes, right? And this is also a feature or a property of fault tolerance, because suppose a data node uh, goes down or fails, then name node can recover the data from the other data nodes, from the replica of your original data, right? That is the replication uh, theory. I will tell you in details later. Okay, functions of name node. So what is fs image and edit logs? This is very important. Very important for interview purpose also. Okay, many interviewers ask these questions that what is fs image and edit logs. Okay, so these are the functions of name node. It is the master daemon. Obviously, name node is the master daemon. Name node is the master daemon. Slaves are data nodes is the slave. Okay. Okay. So it is the master daemon. Name node is the master daemon that maintains and manages the data nodes. That means slave nodes, obviously, and it records the metadata of all files stored in the cluster. Okay. As per example, the location of blocks stored, the size of the files, permissions, hierarchy. Obviously, permissions will be there, hierarchy will be there, etc. There are two files associated with the metadata. One is fs image, another one is edit log. Fs image uh, contains the complete state of the file system namespace since the start of the name node, right? And edit logs. What is edit logs? Edit logs means it contains all the recent modifications made to the file system with respect to the most recent fs image, right? So what is fs image? Fs image means it contains the complete state of the file system namespace, right? So file system namespace, the information about the contains the complete state of the file system namespace since the start of the name node, where when the name node has started. From that particular time, it uh, contains the complete state inside the fs image, right? And edit logs contains all the recent modifications made to the file system with respect to the most recent fs image, right? And recent fs image, the actual information is this: files, permission, hierarchy. Suppose you are transferring a file from suppose you are transferring a file from your uh, mm, suppose you are transferring a file. Suppose you are
you have to transfer a file from your local file system to Hadoop distributed file system, right? So what you will do, you will use put command, right? You will use put command. So for the using put command, when you are transferring the data, when you are putting the data from your local file system to Hadoop distributed file system, that means the data nodes, what happens, the write operation happens. So for that on that write operation, on during that write operation, actually the name before, I mean sorry, the before the write operation, name node will decide in which data node the data will be stored. So what so client, that means you are the client, you have to put your original, your data from local file system. That means suppose I will put this data, I will put CSV data, this put I will put this uh, CSV data from local file system to the HDFS location. HDFS location means suppose this is my HDFS location. Hadoop 50075. 500 is the port number. Okay. So I want to put this. Okay. So what I am the client, right? So what will happen? Name node will decide that in which location of the data, which location, or which, I mean, which location of the data nodes, which in which block these these data will be stored. And obviously name node will decide uh, where these data, where the replica of these data, another two replica of this data will be stored in another data node. That means it will use three data nodes, because the replication factor is 3. So here you can name node will decide. So what name node does, name node will give an URL of the URL means this is the URL. Okay, this is the URL. So node will decide in which location of the HDFS this data will be stored, right? So after deciding of the name node, so it stores the information into the metadata information, and that is the what it is the FS image and edit logs designed for this purpose, right? So metadata has two components, FS image and edit logs, right? Okay. So client cannot put the data directly bypassing the name node. Name node is the master. Name node will decide where the data will be stored and another replica will be stored, right? And when the client, I means I am the client, after putting the data inside the HDFS, I want to, if I want, I will need to read the data from the data node. Name node will help me. Name node will help me. Name node will uh, 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 fetch the information from the metadata, that where the particular data is stored, and name node will help me to get the data. Okay. So okay, fine. Here is I hope you can understand over here from. So it records each change that takes place to the file system metadata. For example, if a file is deleted in HDFS, the name node will immediately record this in the edit log. I hope you can understand the importance of edit log. Okay. It regularly receives a heartbeat signal and a block report from all data nodes in the cluster to ensure that the data nodes are live. If the data nodes are not sending the heartbeat signal, that means the data node is not live, right? Immediately name node will come to recover your data, because data if because the live sorry because the heartbeat signal is not coming from the data node in case of any situation. So heartbeat signal, so it it means name node regularly receives a heartbeat signal and a block report from all the block report, obviously block report as well as the heartbeat signal, all the data from all the data nodes in the cluster to ensure that the data nodes are live. So it keeps a record of all the blocks in HDFS and which nodes these blocks are located. Okay, fine. In case of the data node failure, the name node chooses new data nodes for new replicas, balance disk to balance disk. So somebody asked me what is balance disk in suppose in the Telegram group or uh, suppose in the WhatsApp group, I cannot remember, but somebody asked me that he faced these questions on his interview. What is balance disk? I can remember that, but I cannot remember that in Telegram or WhatsApp. But I have still remember this that somebody asked me that what is balance disk. So balance disk is nothing but balance disk is uses and manages the communications traffic of the to the data nodes, because name node have to balance the total disk usages, right, and manages the communication traffic, right. Yeah, I hope you can understand the communications traffic is I mean have to manage by the name node, right, and the disk usage should need to be balanced. So this is very easy thing. I hope you can understand. If you have any questions, you can ask me. So data nodes is nothing. Data nodes is the HDFS. This is the data nodes. I will not go in details here, and you can check over here that they send heartbeats to the name node periodically uh, to report the overall health of HDFS. By default, this frequency is set to 3 seconds. A Hadoop admin can change the uh, frequent frequency. Okay, if they want as per the requirement. So 3 seconds is default. The frequency is set to 3 seconds. After 3 seconds, the data nodes continuously, I mean periodically sends the heartbeat signal name node, to the name node, right? I will go in details after some time. We will get clear. Okay. So secondary, what is secondary name node? This is very important topic. What is secondary name node? After from these two daemons, there is a third daemon or a process called secondary name node. The secondary name node works concurrently with the primary name node as a helper domain. Okay, so don't be confused with the backup name node, because it is not any backup name node. Okay, this is Hadoop 1.X architect. In Hadoop 1.X architecture, there has only one name node. Okay, not more than one name node. And the secondary name node, what does secondary name node? It is a helper domain. Okay, actually, say what does secondary name node? Suppose uh, in case of the secondary name node, in one which constantly reads all the file systems and metadata from the RAM of the name node. RAM of the name node means here is the RAM of the name node. So metadata stored in the RAM of the name node. So RAM name node, the secondary name node is one which constantly reads all the file systems and metadata from the RAM of the name node and writes it into the hard disk or the file system, right. It is responsible for combining the edit logs with fs image from the name node, right. So it is responsible, secondary name node is responsible for combining the edit logs with fs image from the name node, right. Okay, because APS image has the information from that day where the name node when the name node started, right? So secondary name nodes helps here, and it downloads the edit logs. This is very important point, guys. It downloads secondary name nodes, downloads the edit logs from the name node at a regular interval and applies to fs image. The new fs image is copied back to the name node, which is used whenever the name node is started the next time, right? Suppose in case of a failure of name node, secondary name node helps here. Okay, secondary name node performs regular checkpoint in HDFS, therefore it is called as checkpoint node. So this is also a important interview question, that what is checkpoint node. Okay, 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 fine. So interviewer sometimes asks that what is blocks. Now, blocks is nothing. I hope you can understand that where the data, I mean the data in HDFS is scattered. Your data, your data is in HDFS is scattered across the data nodes as blocks. Okay, I will not go into details in this. Okay, uh, before starting the replication management, I want to see if you have any questions. Okay, so what is replication management? Replication management means in HDFS provides a reliable way to store huge data in a distributed environment as blocks, as data blocks, right? So in blocks replication, you can check over here that this is the node 1, node 2, node 3 and node 4. I hope you can understand that this is the data node. These are the data nodes. These are the data nodes. Okay. Data nodes mean this is the name data node 1. This is the data node 2, data node 3 and data node 4. Okay, and these are the block 1, block 2, block 3, block 4 and block 5. We have colored this, we have colored this to understand, for the data understand. So suppose you have to put your file into HDFS, the name node will decide. Suppose name node has been decided that your data will be stored into the data node 2. Name node has been decided that your data will be stored into the data node 2, right? Data node 2, and the block will be 1, the first block. The name node has been decided. So name node, what will do name node, we will create two another replica of your of this block. This is the replica 1 and this is the replica 2, because 1, 2 and 3 is the replication factor here. In case of this data node 2 fails, name node can recover the data from name node, from data node 4 or data node 1. So this is the replication factor. If you have any question, you can ask me. Here is the another one scenario of RAC 1 is algorithm. These are the racks, rack 1, rack 2 and rack 3. Okay, and 1, 2, 3, 4 are, these are the data nodes. These are not blocks, these are the data nodes. 1 data node 1, data node 2, data node 3 and data node 4. this is the block, this is the block, this is the block, this block, this block, this block. Okay, so you can check that here. If you if green is the this green block has your data, okay, contains your data, and the replication and the replicated data is situated in the fourth data node of rack 1 and 11th data node of rack 3 of your data second uh, data node of rack 1. Similarly, here you can check that for block A, your data, suppose your data is in data node 1 of rack 1, the replicated data is situated in the data node 6 and data node 8 of rack 2. Okay. Okay, so I will finish uh, this topic of Hadoop 1.X Hadoop 1.X. One topic has been left, that is the HDFS read-write architecture. Okay, suppose your block size is 128 MB. Suppose your block size is 128 MB, and you have to put your data from local file system to Hadoop distributed file system, and uh, your block size is 128 MB. Okay, each of your block size is 128 MB. Okay, so what will happen? Your data is 248 MB. What will happen? Your data will be divided into two parts. In one block size is 128 MB, and another block size will contain the 120 MB, and another 8 MB will be empty. Okay, I hope you can understand this. Okay, so um, when you will I mean, when you have to write your data from local file system or any location to HDFS, it may be local file system, it may be any semi-structured or unstructured source of data. So what will happen? First of, I mean, that's these three steps will be performed for the write operation of HDFS. Please attention here. Write operation. First step is the setup of pipeline. Second one is data streaming and replication, and third one is shutdown of pipeline. That is the acknowledgement stage. Okay. So here pipeline setup will happen. Okay. Suppose client node. Here is the here this is the client node. Okay. Client means suppose I am the client. Assume that. Assume. Okay. Suppose I am the client or you are the client. Assume you are a client no? Okay, you have requested from your system to that you have to write your data to the HDFS location. So this is the rack 1, this is the rack 5, and this is the rack 7. In the middle many racks are there. Okay, so first of all, you you are requesting the name node that you have to write your raw data into data node, sorry, into HDFS. So name node, this is the first step of write request. Okay. Block A means, what is the block A? Block A means you have data. Assume that that is the block A. Assume that. Block A means, suppose assume that this is the block A. Suppose this is the, this file is the block A. You want to write into it into HDFS. Okay. Okay. So uh, name node will decide where uh, the where the block A will be stored. What will be the rack number? What will be the data node number? Name node will decide. Okay. So name node has been decided that this block A will be stored inside the data node 1, data node 4 and data node 6 because replication factor is 3. So that's why we have shown you that only the 3 data nodes over here. We have not shown you the all the data nodes over here because the picture will be very large for that. Okay. So IP address is IP address of DN1, DN4. DN means data node. DN1, DN4 and DN6. That means the this is the data node DN1. DN1 is situated inside the rack 1. DN4 is situated inside the rack 5 and DN6 situated inside the rack, obviously rack inside the rack 5. Okay. Okay, fine. So this is the IP addresses of, obviously IP address. If using the IP address, it can be identified, right? So uh, name node has been decided, and name node has been told to the client that that means that has been told you that the data will be stored into this location because name node has manages the disk balances, right? This DN1, DN4 and DN6. Why? Because name node has to manage the disk balances and the traffics communications across the cluster, total cluster. Okay, this is the master and these are the slaves. Okay, so DN1, DN4 and DN6. So this is the second step. Third step, what will happen? What will happen? Using the core switch, this block A, that means this block A will be stored inside the uh, data node 1, data node 4 and data node 6. You can check that first it will be stored in data node 1 and after that using the core switch it will be stored inside the data node 4 or rack 5 and after that this is the replicated data node 4 and data node 6, same data of your original data, raw data, replicated data of your raw data, and this is the data node 6. Okay. So after uh, this is not the only, this is only the pipeline setup. Okay, here the data is not transferring. Okay, uh, don't think that the data is transferring over here. Okay, only pipeline setup has been, that means only a blueprint has been generated. This is the step 1, setup of pipeline. That means name node has been decided that this it will be the data node. So a pipeline has been has been generated. Pipeline means a pipeline has been generated. You can think that um, uh, a way has been generated. The data has not
started transferring still now. Okay. Okay, now the data streaming will start. Data streaming will be start over here because the pipeline setup has already been generated. So data streaming will be start. What client will do, because name node told name node has been decided and gives the information to client, then that the data node 1, data node 4 and data node 6 uh, will be the uh, the data will be stored inside this data node 1 and data node 4 and data node 6. This data will be transferred into the by these pipelines generated at the step 1, right? So you can check that block A is has been transferred into this second step, data streaming and replication. Block A, here block A has come, here block A has come, right? This is the second step. Okay, and after the shutdown of the pipeline, third step or the acknowledgement stage. Here you can check that shutdown of pipeline. Block A, block A is the block A is the your data. Okay, so already transferred or stored inside the data nodes. So after the storing of the data nodes, these data nodes will send a hardware signal and a block report to the name node that we have stored the block A, right? So you can check that from block 6, this block A copied and block A copied. Okay, so this acknowledgement signal from block 6 to block 4 and blocks 4 and block 6, acknowledgement from block 4 and block 6 to this is the second step to blood to data node 1. Okay, and that third step is the acknowledgement from data node 1, data node 4 and data node 6 to the client and write successful message to the name node. Now name node will do the metadata updated. Now name node will update its metadata after the after receiving the acknowledgement signal from the data nodes. Okay. The similar way, read the it was the right HDFS right architectural workflow. Okay, and in this similar way, HDFS read uh, architecture comparably to easy to understand. Okay, this is nothing but suppose you want to read your block A, your block A. Okay, so you want to if you want to read block A, then you have to request you have to read request. You want to read block A and block B, both you want to read, right? Assume that here many blocks are there. You want to read block A and block B. Okay, so you do not know that where the block A and block B is situated, or in which rack, in which. Suppose assume that here uh, thousands of rack are there. Okay, so you do not know where the in which rack, in which data node your block A and block B is situated. Okay, name node knows where your block A and block B, where is your block A and block B. So you are requesting a name node that you want to read block A and block B, and after this first step, second step name node is giving you the IP address of block A and block B, DN1 and DN3, data node 1 and data node 3. After getting the IP addresses of block A and block B. Okay, so you will come to know that your block A and block B is situated inside the data node 1 and data node 3. So where the data node 1 and data node 3's IP address name node gets? It gets from the metadata. Okay, fine. So DN1 and DN3 metadata means APS image edit logs. I told you. If you have many more details, any questions, you can ask me. Okay, in chat box or comment box, you can say anything. Okay, so the DN1 and DN3 IP address client gets the name DN1 and DN3's IP address, and and the third step is that this is the block A, and this is the block A. Three replicated form of the data node. Sorry, block A, and this is the block B situated in the data node 3. This is the actually raw data. DN1 means the block A, your raw data, and these are the replicated data, and this is the your original raw data, and these are the replicated data. So nothing, it's simple that this data will easily can be readable by client, because client knows the IP client gets the IP address location from name node, the DN1 and DN3. So easily it can be readable by the client. Okay, using via the core switch. Okay, fine. So you should have a idea that about this architectural workflow. I don't know. Uh, I think you have a pretty good idea from this diagram. Okay. Okay. So what is job tracker and task tracker? You may have a question that what is a job tracker and task tracker. I have told you about the name node and data node, right? So what are the job tracker and task tracker? So job tracker and task tracker are two essential process involved in MapReduce execution in MapReduce version 1, that means the MapReduce or Hadoop version 1. Both process are new deprecated in MapReduce version 2. Okay, so both process are new. Both processes are now deprecated in MapReduce version 2 is and replaced by resource manager and application manager and node manager daemons, which is the yarn. Yeah, uh, yarn is the yarn has come in the Hadoop version 2. It is replaced the Hadoop version, MapReduce in, uh, in the Hadoop version 2. Yarn has come. Okay, job tracker and task tracker replaced by the resource manager and application master. Okay, so what does job tracker in Hadoop 1.X? Job tracker process runs on a separate node and not usually on a data node. Okay, so job tracker is an essential domain for MapReduce execution in MapReduce version 1, which is replaced by resource manager or application master in MapReduce version 2. So job tracker receives the request for MapReduce execution from the client. You know that job tracker obviously job tracker will receive the request from the MapReduce execution from the client.
Okay, when the MapReduce job will, I mean, before uh, your job submit into the MapReduce engine, MapReduce uh, uh, job submission of I mean job submission of during the job submission, job tracker receives the request from MapReduce execution from the client. The job tracker talks to the name node to determine the location of the data. Okay, and job tracker finds the best tracker nodes to execute tasks based on the data locality. Actually, I will go in these things into details. You may not understand that what I am talking about this right now. Whatever what is job tracker and task tracker. I am finding a diagram for you for better understand. Just a second. 1 second. Many of you has asked me question. Please explain previous example before block application image. Okay, block replication image. Balachandra asking me that to explain previous example before block replication image. 1 second. What is the okay? Which example? Please tell me the specific topic, Valachandar. Please tell me the specific topic that I can understand that in which topic you want to understand. Okay. Before block replication image, I didn't get it. This. Okay, please tell me the specific topic. Okay, data replication behavior changed in future. Hadoop version 3.x. 3.x. Okay, I have not heard about 3.x, but I have to because I have not searched about 3.x. So it may have 3.x is coming. I mean, maybe I don't know. Okay, so I have not heard about Hadoop version 3.x. This is my first time that I have heard about Hadoop 3.x. I know about Hadoop 2.x. Dinu Suite has asked me. Okay, so data replication behavior changed in future. Data replication behavior can be changed in Hadoop 1.X, bro. No problem will be there because Hadoop admin can change the data replication mm, if they if as per the requirement. Okay, okay. So and who will break data into blocks is name node or data node. Okay, okay. No, no. Who will break the data into blocks? I will tell you about this. No, not name node is not breaking the data. I will tell you in details about this. Before that, you have to understand the uh, MapReduce obviously and the job tracker and task tracker. Actually, what happens when job tracker receives the job? Okay, it submits the job to the actually the task tracker um, uh, uh, helps to break the data, and you have asked that who will break the data into blocks. Obviously, here you can check that, this is here task tracker helps to do this. I am showing you an example of job tracker and task tracker before saying you about job tracker. Okay, please check over here. Okay, this is the MapReduce engine. This is the HDFS cluster. Okay, job tracker. That is the name node can talk with job tracker, and task tracker can talk with data nodes. Okay, so who splits the data? Actually, task tracker splits the data, and okay, so task tracker splits the data, and here the MapReduce uh, job performs. And where in this admin node, this is the name node, which is the master, and name node can talk with job tracker, and task tracker can talk with data node. Okay, this is, please check this. This is very good diagram. You can check over here. Okay. Okay, core switch is nothing, but core switch is not more important. Core switch is nothing. Core switch actually, what does core switch? Okay, okay, 1 second, just a second. Core switch is a virtual uh, component over here. This core switch, right? You are asking about this quest about me about this quest core switch. Core switch is nothing. You can, it's like a virtual component. Okay, where it manages all the data. Suppose you have to write data to the across the cluster, right? This is the total cluster, right? This is the total cluster, am I right? So this, in this total cluster, are you getting me? This rack 1, this is the rack 5, this is the rack 7. Suppose here thousands of racks are there. Okay, and in every each and every rack contains many data nodes. Okay, not 6 data nodes. Assume many data nodes are there in each and every rack. Okay, so each rack is uh, managed by a switch. Okay, and this switch can should be managed by the core switch, right? There should be a manageable core switch over here. Otherwise, how you can store the data to the particular rack, right? Some some a coordinator should be here, should be present over here to store the data. uh, so here this is the switch. These are the switch contains in every rack of the cluster of the Hadoop uh, distributed file systems cluster. Total, in this total cluster, every rack contains an individual switch, and every switch is unique switch. Unique switch. Okay. So every unique switch can be identified using the core switch. Okay. So core switch helps to identify the rack. Core switch helps to identify the rack over here. I hope Prince Keher, I hope you can understand that what is core switch and switch. So okay, okay. So I was telling about this diagram. Now check over here. Task tracker runs on data node. Okay, mostly on all data nodes, because here you can mostly on all data nodes. Task tracker runs, right? You can check that task tracker can talk with data nodes, right? Here is the data node, here is the task tracker, and this is the name node, this is the job tracker. Name node can talk with job tracker, right? Job submits to the job tracker, and job this job split into the task tracker. So mapper and reducer tasks are executed on data nodes administrated by task tracker, right? Mappers and reducers tasks are executed on data nodes administrated by task trackers. So task trackers is the admin for mapper and reducer tasks execution. So execution of mappers and reducer tasks on data nodes, task tracker is the administrator for this. Try to understand this. I will tell you about the MapReduce. That will be the last topic today's live session. Will be okay after Hadoop 2.X. But try to understand that I wanted to tell you these things after the MapReduce workflow. Okay, because anybody uh, may not know about MapReduce, because many of you, I mean, who know about MapReduce, that is be fine. But anybody of you may have fresher, or because somebody told me that we are fresher, we want to learn uh, from ground level. So that's why I wanted to tell you. I uh, by thinking about all persons that I can tell, you can understand if you know the MapReduce. Okay, so task tracker is the administrator for the MapReduce tasks. Okay, so task tracker will be assigned mapper and reducer tasks to executed by job tracker, right? Okay, and task tracker will be constant communication with the job tracker, signaling the progress of the task in execution. And task tracker failure is not considered fatal. When a task tracker becomes unresponsive, job tracker will assign the task executed by the task tracker to another node. It is very simple process. I hope you can understand that, but it will be more clear when you will do a MapReduce workflow. Okay, job tracker process is critical to the Hadoop cluster in terms of MapReduce execution. When the job tracker is down, HDFS will still be functionable, but the MapReduce execution cannot be started and the existing MapReduce jobs will be halted. So you can understand a concept that task tracker can talk with data node, job tracker can talk with name node, and job tracker can submit this job to the uh, task tracker, where map portion and reduce map task and reduce task execution. So where the task tracker is the administrator of the map task and reduce task execution. Fine. Okay, after the data splitted, okay, splitted, and it stores into the blocks of the data nodes. You told me that where how these data nodes, I mean, splitted data are splitted. So these are the internal process. Okay, so let me go ahead. Let me move. I am. You may have a question that does deleting a file. One second. So one second. Does deleting a file removes all replication files as well in HDFS?
Tapaswini Jena asked me that what is the responsibility of core switch. Tapaswini, I have already told you about the responsibility of core switch. I have already told you about the responsibility of core switch, Tapaswini. I hope uh, that core switch is the uh, core switch helps to indicate the rack position. Okay. I mean, core switch helps to indicate the unique rack or particular rack, because individual rack contains switch, unique switch. Each and every rack contains unique switch. So when you as a client want to write or you want to read a block from HDFS location, right? So you have to uh, read the data or write the data, right? You have URL or the location of that data node. So all the data nodes in the cluster are not scattered in okay. It designed it every it designed in this way that every racks contains many data nodes, okay, and there is a thousand of racks, thousands of racks. So racks contains the data nodes. So rack contains the each and every, I mean racks contains the data nodes. So each and every racks uh, uh, sh- uh, contains the switch, okay, to identify the rack. So that's why that's why uh, a core switch has been designed to manage or to identify the exact rack. Okay, so core switch will indicate a particular rack by indicating the switch of the rack. Okay, because every rack contains switch. So core switch can identify a rack by pointing the switch of the rack. Okay, I hope you can understand. So does deleting the my question is that does deleting a file removes all replication files as well in HDFS? Is trash the only way to recover deleted files from HDFS? Replication factor is only used internal by framework for fault tolerance and any network or other failures happens. Okay, so the answer is a file in HDFS can be removed using RMR command. Okay. So, however, HDFS supports trash features. So, if you have deleted if you have deleted your data from HDFS location, so it is, I mean, uh, still is available, because when the trash features is enabled, because you can enable the trash feature. Okay, so when the trash feature is enabled, a file is moved to the .trash folder, right? So under the users HDFS directory. So however, internally how it works is that HDFS will just create metadata in the trash folder to identify the file and the associated block information that needs to be deleted once the file system fs.trash interval, okay, uh, time interval is completed after the file is deleted. So if the user wants to recover the deleted files, all that is done is delete the metadata information from the .trash folder, and the original data is anyways lying on the data nodes as usual. Okay, so you can understand this happens because of the replication uh, factor theory. And what happens, I am asking you a question, that what happens when all the data nodes fail in Hadoop? What will happen? Suppose all the data nodes fail in Hadoop, what will happen? If all the data nodes fail in Hadoop, a new replication pipeline containing the remaining data nodes is opened and the write resumes. Okay, at this point things that are mostly back to normal and the write operation continues until the file is closed. Okay. Uh, Suppose here is an example I am showing you. This suppose name node told the client to write block D1 to data node D1 in rack 1 and D2 in rack 2. Okay, data node D1 in data node D1. D1 means data node 1 in rack 1, data node 2 in rack 2. Block B will be write. Where will be it will write data node 1 in rack 1, data node 2 in rack 2 and data node 3 in rack 1. Fine. There might be other racks also in the cluster, rack 4, rack 5, rack 6, etc. Dot. If rack 1 and rack 2 failed, okay, during the write process, client knows that the data was not written successfully. Since it didn't receive the acknowledgement from the data nodes, obviously, because data nodes periodically sends acknowledgement signal to the name node. At this point, will it ask name node to give new set of data nodes? So actually, what happens if the block writes fails in the first data nodes? It will be abandoned the block write and ask name node in new set data nodes where it can attempt to write again, because name node is the master over here. So it will ask the name node to set up the data nodes to a new set of data nodes where it can attempts to write again. It will be happen. This is the answer. Okay, I hope you can understand now. These types of tricky questions, I have seen that interviewers sometimes asks. Many interviewers ask these types of questions because bookish knowledge is not enough to learn. Okay, uh, if you have good concepts, then you can crack the interview, because these types of questions many times I have seen, I have heard many times these types of questions, because this is conceptual question. Okay, let me go ahead. uh, um, I think today I cannot show you any Hadoop comments. Hadoop comments is, I think, HDFS comments. I will not show you today because due to lack of time. So HDFS comments. If you ask me any, or you can tell me that to show you HDFS comments in another day. Okay. Most all of you know that what about the HDFS comments. That's not a big deal. And uh, now I am going to. So these are the Hadoop 1.X. Okay. Uh, Now Hadoop 2.6. I'm going to show you the Hadoop 2.x high availability cluster architecture. Okay, I will not go in very details over here. Okay, I will tell you point by point. I will not read
in details over here. I will not go through in details over here because many it will take many times. Okay, I will not go through line by line. I will just show you a image and I will describe by myself. Okay, and you can ask me any questions here the comment box. Okay, so and guys, if you have any doubts or questions, you can ask me on Telegram group or WhatsApp group also. I will try to answer your question. And okay, so what is the Hadoop 2.X high availability cluster architecture? High availability, sometimes it called HA. Have you heard about this? Hadoop distributed file system high availability cluster, sorry, architecture. Here, the concept high availability cluster was introduced in Hadoop 2.x to solve the single point failure problem of Hadoop 1.x. Single point of failure problem. Okay. Okay. So as you know from my previous, one second, just a second. Okay. After this Hadoop 2.x architectural workflow, I will show the MapReduce workflow, and I will show a reduce side join partitioner combiner, a small program, and after that the it will be end. Okay, so you know about that in Hadoop 1.x, as you know from the my previous blog, that the HDFS architecture follows master slave topology, where the name node acts as a master daemon and is responsible for managing other slave nodes called data nodes. Right? You have already known about this. Okay, you have already learned about this. So this single master daemon or name node becomes a bottleneck. Although the introduction of secondary name node did prevent us from data loss and offloading some uh, burden of the name node, but it did not solve the of availability issue of name node. Right? Okay. So name node availability. I'm talking about this topic. If you consider the standard configuration of HDFS cluster, the name node becomes a single point of failure. It happens because the moment of the name node becomes unavailable. The whole cluster becomes unavailable until someone restores the name node, right? Or brings a new one, right? Suppose name node fails. What will happen? Suppose name node fails. One name node was there in Hadoop 1.x architecture, right? In Hadoop 1.x. So if the name node fails, what will happen? You have to restart the name node, right? Or you have to bring a new one, right? So name node availability questions comes into uh, over here for the Hadoop 1.x. But in Hadoop 2.x, we have configured the more than one name node. I will tell you. So the reason for unavailability of name node can be a planned event like maintenance work such as upgradation of software or hardware, or it may also be due to an unplanned event where the name node crashes because of some reasons, right? It may happen. Name node fails or name node can be goes down due to this reason, right? Okay. Now HDFS high availability architecture. Let us understand that how HDFS high availability architecture solve this critical problem of name node availability. The high availability architecture solve this problem of name node availability by allowing us to have two name nodes in an active or passive configuration. Okay, so you can check that you can see over here that there is two name nodes, active name node and another one is passive name node, right? Passive name node means it will be in standby mode. Here is the active name node and here it is the standby name node. Okay, here it is the active name node, here it is the standby name node. Okay, and these are the data nodes, HDFS, right? Try to understand this. Try to understand this diagram. Okay, this is the active name node, this is the standby name node. Standby name node stays in standby mode. Only one name node can run at one time. Okay, two name node does not run at a single time. Okay, standby name node takes place the another name node if the active name node fails. Okay, and so you may ask a question. You may ask me a question that how the standby name node uh, will get the information from the metadata uh, uh, or the data nodes send the heartbeat signal to the active name node periodically. So you may ask me any question. You may ask me a question that Bhaskar, you tell me that uh, how standby name node uh, 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 can learn. Sorry, can know that it is uh, the data where the data nodes heartbeat signals are coming from, which data nodes are coming and where the metadata informations are there. So actually here journal nodes is helping over here to share the edit logs to the two data nodes. Okay, journal nodes mean here that you have to, you can check over here that here three journal nodes are there. Okay, for fault tolerance purpose we have designed three journal nodes over here. Here you can check that three journal nodes, one journal node second and this is the third one. Okay, this is the active name node, this is the secondary name node, sorry, standby name node, I'm sorry, standby name node. Okay, standby name node. So these three journal nodes, these three journal nodes is called a single journal these three journal nodes is called uh, together is journal nodes. Okay, so data nodes sends the block report and the heartbeat signal to the active name node and the standby name node. Okay, both, each and every data nodes. Okay, you can check uh, from this uh, pointer. It will be easily understandable for you, and these active name nodes update the metadata information. Only active name nodes can update the metadata information, edit logs to the journal nodes, and journal node syncs these two, active name node and standby name node, at a single point of time. Journal node syncs these two, this both of name node at a single time, and so that if active name node fails or goes down, standby name node takes place. Standby name node can takes place the active name node. Okay. Uh, so this is a very simple and very good design by the uh, Hadoop architecture who designed this architecture, high availability of Hadoop version 2. Okay, so here uh, monitor status and health, manage high availability state, failover controller active, zookeeper service. See, zookeeper is a coordinator distributor. Coordinator, if it coordination done by the zookeeper. Okay, zookeeper is a very big topic. I will not go in details about zookeeper because it will take many times. A half, a one by third uh, time of a total session uh, will is needs to describe the zookeeper. I will not go into details, but you you just learn that a zookeeper service actually co- coordinate this failover controller these journal nodes, and journal node syncs this active name node and standby name nodes. Okay, and data nodes sends the block report and heartbeat signals to both name nodes. Okay, so I hope you have a pretty good idea about this workflow. Okay. Okay, so next I will tell you about the implementation of Hadoop ability high availability architecture. Okay, so using quorum journal nodes and the shared storage NFS. This is nothing but where I will not go into details about this. Okay, because due to lack of time, I will not go into details about this. These data nodes sends the block reports and heartbeat signals to the both of the active name nodes and standby name nodes. Standby name nodes stays in standby mode, and active name node works over here. Okay, don't be confused. Two name nodes cannot run at a single time. Okay, and these are the journal nodes. You can what is the purpose of journal nodes? Because you know that a name node updates the metadata information about the data nodes into the I mean name node updates the metadata information. Okay, okay, so that's why journal nodes is needed, and name node updating the metadata information. You can check the pointer over here. Here pointer is goes from here to here, name node to journal nodes, and journal nodes sending, I mean syncing syncing. Okay, uh, is my route pronunciation? I don't know. SYNCING. Okay, syncing the both of the name nodes. Uh, okay, so data nodes are configured with the location of both name nodes and same block location information and heartbeat to both. It is very good. I mean, diagram. I hope you can understand that. Okay, and another one. This is one procedure to design a architectural work to design a Hadoop 2.x architecture. But if you want, if you don't want to, if you want, you can change journal nodes. I mean, you can replace the journal node by shared direct TNFS, namespace edit logs to share storage. These are the two process. Any one of these two process you have to follow. Any one of these two process you have to follow. Okay, any one of these two process. Okay, I think this is recommended. First one is recommended using quorum journal nodes. This is the only shared directory on NFS. It does same thing what journal nodes does. Okay, and I will not go into details about these things. And automatic failover, where Zookeeper comes into this picture to help the fault tolerance. And I mean, you know that I don't know you know about HBase or not. In HBase, these types of scenario are there. I do not know. Do you know HBase architecture? Have you gone through? So it is the journal node which decides that which name node will be the active name node. Uh, no, not like that. No, 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 not like that. So listen, name node will decide that who will be the master. Okay, name node is the master. So master, no one can decide that who will be the master, right? Right. Here is the Hadoop is the master slave architecture. Hadoop is designed in a master slave architecture. Okay, so if you uh, can see that one has master, another uh, uh, things over here are slaves. So you are saying that masters can be decided by another one. No, 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 not like that. General node cannot decide that who will be the active name node. It is by default set up by the admin. Okay, that active name node will be this and standby name node will be this. Okay, so you have two machine, one is active name node and another one is standby name node. You are a Hadoop admin, so you have set up the active name node, and other one will be second standby name node. It will be run as you have designed. Okay, I hope you got your Prince Kehar. I hope you got your answer of your question. Okay, so now these are the zookeeper. Okay, I will not go into details about this, and you can check over here. The zookeeper is the coordinator. Okay, uh, I will not I will tell you about the zookeeper in another day. Okay, so here it is the difference in between Hadoop 1.0 and Hadoop 2.0. So federation is designed like this way, that one name node in and namespace in Hadoop 1.0, and Hadoop for Hadoop 2.0 multiple name node and namespaces will be there, right? High availability is not present in 1.0. High availability means the name node availability. Okay, for name node availability in Hadoop 1.0 is not present, but in 2.0 is present. I hope you can understand why it is highly available. If you cannot understand, still cannot understand, please ask me, I will tell you. And yarn processing control is the yarn processing control is a job tracker and the task tracker over here, and job tracker and task tracker is replaced by resource manager. Okay, and the node manager in the Hadoop 2.0. Okay, respectively. And application master does another thing. I will if you want, I will discuss about yarn in another day. Yarn is very simple and very important topic also. Okay, and another important Hadoop 2.0 features are HDFS snapshot in NFS v3, access to data in HDFS, support for running Hadoop and MS Windows. These are the features and substantial amount of integration testing with test of. These are the features. I hope you can understand that. I will not go through in details. And Okay, check over here that here is you can check that this is the Hadoop 2.0 cluster architecture. Okay, you cannot find job tracker and trust tracker over here. You cannot find job tracker and trust tracker over here. Here manager here is this is the resource manager. That means Hadoop 1.0's job tracker. This is the job tracker, but it is replaced by job tracker is replaced by resource manager over here. And these are the I will show this picture over here. This is the job tracker. See, job tracker is replaced by the resource manager, right? And job tracker can talk with name node in Hadoop 1.0. I told you, you can see that resource manager can talk with active name node, right? Can talk with active name node, yes or no? Tell me. Task tracker can talk, sorry, okay. Task tracker can talk with data nodes. Here you can check that task tracker means node manager. Node managers can talk with data nodes, yes or no? Okay. Now map tasks and reduce tasks administrated by task tracker. I told you, right? Here you can check that Yarn's node managers, this is the task trackers, I mean node manager, container and application master. They helps to do this, their job. Okay, what task tracker uh, I mean the task tracker's job, the same thing replaced by the node manager over here. I hope you can understand that. And this is the Hadoop 2.0 architectural cluster architecture. And here they have used shared edit logs. They have not used journal nodes over here. They have followed the second step. This is the uh, this steps they have followed. Shared storage and namespace. Okay. So it is journal nodes. Prince Kehar is asking me. So it is journal nodes which decides that which name node will be the active name node. No, no. I told you about these questions and I answered this question. Okay. Bulbul Singh is asking me that I am not so clear for the answer which you explained for what happen if all the data nodes fails in the cluster. Please explain once. Okay, I will explain that once again. And if active NN fails, then how does secondary name node becomes active name node? No, no. Secondary name node is not coming into this picture. In Hadoop 2.x, where you can find the secondary name node? Where you can find the secondary name node? Tell me. Okay. You there is no secondary name node. I told you. one second. Here you can check that there is no secondary name node over here. Here is another one is active name node, another one is standby name node. Secondary name node is the concept of uh, Hadoop 1.0 architecture. Don't mix up, okay? Don't mix up with Hadoop 2.X, okay? Okay. So see over here that if one name node goes down, the other name node can take over the responsibility, right? And therefore reduce the cluster downtime, right? This standby name node serves the purpose of a backup name node, unlike the secondary name node. Fine, which incorporate failover capabilities to the Hadoop cluster. Okay. Therefore, with the standby name node, with the standby node, that means the standby node, we can have automatic failover. Okay, a name node crashes unplanned event, or we can have a graceful failover. Actually, name node fails into two parts. The failure of name node is divided into two parts. One is unplanned event, another one is manually initiated. Okay, unplanned event means suppose name node crashes by itself. This is the unplanned event. Okay, and suppose uh, there is a manually initiated. That means you want to update, you want to restart name node for any reason or for any requirement. See you that is the manually initiated. Okay, so there failover controller standby the automatic failover uh, coordinated by the zookeeper service. Okay, I will not go into details about the failover portion because I we do not have much time because it is already many times that's why there is no time to say you in details because it will take more time if I start to this automatic failover then it will take any another day I will describe this. Okay, it will take many time. This is not the small thing you can check over. Okay, I will tell you about this zookeeper and all. It will take many times, but you just you remember one thing that grace failover and automatic failover is the grace failover is the routine maintenance. Is the mainly I mean manually initiated, and automatic failover means is the unplanned event. Okay, so zookeeper actually coordinates. Actually maintains small amounts of coordination data, informs clients changes in their data, and monitors clients for failures. Okay, zookeepers always monitors. Okay, so I do not know that you know about you know do you know about edge-based architecture? There has also a zookeeper. Okay, and there has also a uh, there is also two master uh, H master. Okay, so uh, zookeeper periodically receives the hardware signals from the H master and the H region server in H base. So in case of any hardware signal is not coming it from the H master, the another standby uh, another H master will take place on that. Okay, on that position. So this is the uh, process zookeeper works. In this process, zookeeper actually works. Okay. If you have any questions, you can ask me. After that, I will go. I will move to MapReduce after this. Prince Care, I told you that what passive does, what passive name node does. Passive name node, nothing. Passive name node is a standby name node. It just wait for the situation when the active name node will fail. Okay, fail to work or goes down. Okay, on that time, standby name node will be active, and active name node will return to standby name node. And because this 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 design, I mean this architecture has been designed to for the high availability of the highly availability of the name node. So you can understand that in Hadoop 1.0 architecture, there was one name node uh, on that time. If the name node was down, so we have to manually restart the name node. So it took many times to restart the name node. And but here the story has been changed because of the two name nodes. If the active name node goes down or fails to in any reason, grace failure, okay, graceful failure, or any unplanned event failure, okay, what will happen? Active name node will fails to work. Then on that time, standby name node or passive name node will standby name node or passive name node will take place of that active name node, and then standby name node will be active mode. Okay. And active name node has the same information which have the standby name node, because here shared edits, I mean journal nodes are sharing the metadata information to active name nodes to and standby name nodes periodically. Okay. And obviously active name node as a standby name node or passive name node uh, receiving the block report and heartbeat signal from each and every data nodes periodically. I hope you can. I hope you got the answer of your question. Okay, I'm moving to MapReduce. Okay. Uh, as the data is the same in both active name node and standby name node, so in this way the standby name node becomes the active name node. Yes. Okay. 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 Uh, so let me start the MapReduce, Apache MapReduce. Here you can check that uh, I will show a word count program, Java. So word count program, I mean word count program using Java uh, over here. But before that, I will try to. I would like to uh, show you the uh, overall MapReduce word count process. Okay, I hope most of you have done this word count process, MapReduce word count process. So one is input, and another side you will get the, if you give the input, and another side it will give you the final result, right? Okay, so before that, please ask me if you have any questions uh, up to this, up to now what I have covered. Okay, you can ask me on chat box. Okay, so you have, suppose you have an input, and you in this input, you suppose, assume that you have a text file, right? Suppose you uh, have a text file, right? And you want to in that text file you want to uh, count the words, right? So assume that in that text file, it is written the deer beer river car river deer car beer. Okay, so it has three records in one tuple. So you will get the final result like this way. What will happen inside this uh, MapReduce word count process? This is very simple process. Okay, I'm trying to show you that this data set, this is the data set, right? This data set will split, one second. Okay, okay, this data set will split into the three uh, individual sub data sets. This is the first data set, this is the second, and this is the third one, right? Okay, now after splitting, it will get key and value pairs. So what is the key and what is the value over here? Try to understand why it is the key and what is the value over here. Here value is, this is the value, deer bear river. Okay, this is the value, and I'm talking about the input. Okay, that input is long writable is the input, and value is the what? Value is the total data set. Now uh, we will write a mapper class, and we will assign a constant one to each and every word by tokenizing the record. And after that, shuffling process will be there, and shuffling process is divided into two portion, part. One is merging, another one is uh, sorting. And merging process is divided into two steps, and one is merging one and merging two. I will tell you in details after some time. After the shuffling process, you can check over here that here beer, car, deer, river, right? So beer means this in from these three subdata sets, this from these three subdata sets, beer is taking from uh, uh, yeah, beer is taking from these three subdata sets, and the all ones into a single uh, key. So here key is beer and list of value is 1 and 1. Okay, like this. Here you can check the list of keys and list of values. Here no list of keys, only one key, and the value is list of value. Value means 1 and 1, and reducing means they have reduced, I mean it has reduced. You can check that 1 and 1 it has reduced to 2, and after that this is the list uh, uh, of key value pairs. Okay, so let me describe this example, that what is be the what count, I mean what is the what count programs imported classes. Okay, so this two is needed for this one is needed for the exception purpose. This is needed for the string tokenizer util packages. You know about that. Who are the Java developers? They are already known very well. And in Hadoop, string of Java, that means in Java, what we write? In Java, we write string, right? We declare a string variable as a string, right? But in Hadoop, Apache Hadoop, there is a class text. Okay, you can check over here that just a second. Okay, uh, see that what we write in Java string, that we will write text, I mean text writable in Hadoop MapReduce code, Java code. Okay, and what we write in object in Java, that we will write object writable and int writable in uh, Hadoop, which is the same things Java's primitive as int. Okay, short is short writable, byte is byte writable, boolean is boolean writable in MapReduce Java code, but in Java it was boolean. Float is float writable, long becomes long writable, double becomes double writable, int becomes int writable. Okay, I hope you can understand that. And now we have imported this configuration class, and it will use in the driver class of the uh, uh,
MapReduce program, MapReduce WordCount program. So MapReduce program, in each and every MapReduce program, you have to write the driver class. Okay, so this is the main method. You can check. This is the main method. Okay, and here we have written the uh, uh, we have configured the job over here. Okay, and I told you that there is two mapper task and reducer task in a Hadoop job, performs in Hadoop job, right? One is mapper and mapper task, another one is uh, uh, reducer task. So in mapper task, this mapper, I mean this what it mapper uh, class does. Actually, this mapper we have created a class tokenizer mapper that extends the class mapper which is already defined in the MapReduce framework. So here this dataset has deer beer river car river, right? So it will take first this is the key and this is the value and this is the input. Key and value is the input, and mapper class will take this object and takes as a key value pair as an input, and it will give the output as a key value pair of text and int writable. Okay, object means here long writable. Long writable means long in Java. You may ask me that what is long, why they have used long writable. Okay, if you write long writable over here, no problem will be there. Same thing. If you want to if you write long writable, then you have to write long writable obviously over here. Okay, so you may ask me that why they have used object over here, and why this is text and why key value pairs, because mapper class is designed like this way. You can check the uh, one second, you can check the uh, uh, signature by going go to if you go to the documentation, then you can check the signature. The mapper class actually designed like this way, so it takes the key value pairs in as an input, and it gives the output as a key value pairs, and this is the long writable and this is the text. So what is the long writable is the randomly generated byte offset key. Byte offset key of what? Byte offset key of the first record, second record, and third record of the of your original dataset, right? Of your original dataset, right? So this input actually it will take the you are submitting your job, so it will take the uh, your data, and it will uh, 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 take as an input as a key value pair. Okay, so and it will give the data as a text and int writable. Key is the text, this is the output. I mean the text will be the key. Text will be the key when it will give the output, and int writable will be the value. Okay. Okay, here is you can check that we have initialized the int writable and text uh, classes, and here we have set one over here. One is the object over here, and what is the text object over here, that means string object, Java string. And here one is the integer, which is we write int writable in MapReduce, right? So Here you can check that this is the object, that means the here this is the object, this object is the byte offset key. I will tell you how the byte offset key is generating. Okay, I will tell you why the byte offset key is generating, why how, who is the responsible to create this key value pair, who is responsible, because how this is happening, how this is happening, right, how this is happening, who is the responsible. Okay, record reader is responsible. Okay, I will tell you about the record reader and input split. But before that, we have to go through these. Okay, so you can check that here is the object and text and context helps to read the operations over here, and it throws the IO exception, interrupted exception. So string tokenizer initialized an ITR object over here, and a value is the value. This is the value. Sorry, this is the value. TR river. Okay, and it's tokenized by string tokenizer. You can understand what is string tokenizer. Who do not know what is string tokenizer, they can check over here what is string tokenizer. Okay, what is string tokenizer? String tokenizer tokenize the word. Okay, so suppose you have a Java, you have imported uh, the string tokenizer over here, java.util the string tokenizer, and class is simple, and then inside the main method you can check that string, you have initialized the class, this is the your uh, data. So you will get the output like this way, because you have tokenized the record by using the delimiter of space. Okay, and I mean, you can check that here string tokenizer has more tokens class, sorry, has more token method, and by these object you can access this method, and you can next token method helps to find more tokens are available, whether has more tokens or not, and it will give you this output like this way. Okay, okay, that's why string tokenizer is needed for here. So Hadoop has own packages. Okay, own uh, self created packages by Apache Foundation. Okay, Apache Foundation has created own Hadoop packages. So we have to import the string tokenizer util by importing the util package, right? That's why we have imported the util package. So you can understand that yeah, Java does not support the text format of MapReduce, Hadoop MapReduce, right? So we have to convert the value. Value means this is the value. Each and every For each and every key, this is the value. So we have to convert the. This is the text format, right? This is the text format. This is the value. This is the value. So this is the value, and map method takes this value over here. This is this map method, don't be confused, like, because this map method designed by this way. Okay, if you go to the signature of this map method, you can check over here. You can check over here. This is the signature. uh, Here key is the line offset and value is the actual text. Okay, okay, fine. So string tokenizer ITR has initialized, and this value we have to convert to string, because you know that Java does not support text format. So text, we have to convert the text to string format, right? So okay, after converting the text format to string format, it will uh, simply it will perform this while loop, and This is the word object over here. And it will set to the itr.next token, and it will write the through the context. I told you that it helps to write operation over here. Here, this is the context object. It do the through the context object, we can write here key value pairs, uh, and word is the key and one is the value. Word means what is word over here? What is word over here? Word means dear one. Okay, like this way. Car one. One means what? One means one. This is one. This is the one object. Okay. Okay, fine. So here you can check that. One second. Okay, I will tell you, Bulbul. I will tell you about the features you have asked me in uh, separately later, but let me finish this. Okay. So you can check over here that here key value is has been generated, and the output of mapper class is the input of reducer class. Okay, that's why text and iteratable over here. This is the text and iteratable over here. So this is the input and this is the output, right? Fine. Okay, so here we have initialized the iterable class of okay, and reduce method we have this is the predefined method. Map method and reduce method are the predefined method. Okay, so text is as a key iterable we have used because we will use iterable because we have these types of scenario. That's why we have used iterable. One. That's why we have used iterable. It will help us to achieve our output and context. We will use context over here. I hope you can understand because context will help us to achieve the right operation. Okay. So this is the member variable over here. Sum is initialized using 0, and this for each loop for each and every values means the uh, values means this output of the uh, one ones, the ones, many ones. Okay, it it will count the sum counts the total ones. Okay, and finally it provides the output to the result. And key is the key. That means the suppose dr is the key, br is the key, card is the key, and result will be suppose 3. Suppose dr 3. Here you can check dr 2, card 3, dr 2, river 2. These are the result. Result means this is the result dot set because sum is the counted value, so that's why counted value is over here. It is very simple Java program if you observe. Okay, and this is very important question because many interviewer ask to describe the driver class. I have seen that. Okay, many interviewer uh, uh, asked to describe the driver class. This is very simple. Configuration, you have to initialize the configuration class and you got the conf object. Okay, you are suppose why we are doing this. Suppose you have to create or you have to run multiple MapReduce jobs. So you can do that. You can do that easily. Here job you have here job 1, job 2, job 3. By using the job 1, job 2, job 3 object, you can uh, call this you can pass this mapper class and reducer class to this class set mapper class, set combiner class, set reducer class. Okay, set mapper class is the predefined class and you are passing the tokenizer mapper class. That means this is the token our user defined class, tokenizer mapper class. We are passing this into some reducer class and combiner and reducer. I will tell you in details about combiner and reducer. In some reducer is the same class will be used in combiner and reducer, and output key and output set output this using this job object we are we are writing all of this. We are passing our classes you to this classes parameter. You can check over here. You can if you want to run multiple jobs, if you want you can do that. Okay, so this set output key class you have to obviously text dot class. Why text dot class? Because your key is text, right? Your key is text. This is the output and this is the uh, sorry, 1 second. No, 1 second. Yeah, this is the output and this is the output key and this is the output value of reducer class, right? So that's why we have written that set output key is the text and set output value class will be iterable dot class. You know, file input format dot add input path, file input format and file output format. We have here imported the file input format. Okay, file input format is nothing. It's taking the input because you have to you are when you run the MapReduce job in command prompt, you write that Hadoop jar file name, package name dot class name, input path, and last you write output path, right? That input path is argument 0 and that output path is arguments 1. So this helps to create the add input path, and our add out set output path is designed for this purpose. Okay, this is the arguments 0, it takes the input, and arguments 1 is gives the aggregated output. Okay, and this is nothing but system.exit. It asks that completed or not, job is completed or not. If yes, then it will be it will be exit. Okay, this is the description of the driver class. Now, okay, now I want to tell you one thing. Just a second. I will not go into very details over here because many times will take over here. I will not go into details. It will take many times. I will just show you very easy example. It will clear everything. It will clear your concept. Just a second. Just a second. Just check. See over here. This is our input. Assume that this is our input. Okay. Okay. Assume that this is our input data set, right?
this input data set, uh, what it has written: red, blue, green, red, blue, green, and the second record is white, black. Third record is red, white, black. Like this way, seventh record is there, right? Okay. So after this input data set, you can check that the split, you have to split the data set. So splitting the data set, what who splits the data set, here? Input split splits the data set. Okay. And input splits, when the input split splits the data set into sub data set 1 and sub data set 2. Okay. This is the first three record splitted into subdata set 1, and last four records splitted into subdata set 2, right? Now shuffle portion will be performed after the splitting. I told you that, one second, I told you the splitting portion has been done, right? Splitting portion is done. Okay, after splitting, what what is, sorry, one second. Yeah. uh, uh, After splitting, it's mapping and uh, shuffling, right? So check over here, the shuffling question is, after mapping means you are assigning each and every, I mean you are tokenizing the each and every record and assigning each and every word to one, right? You have done this. Okay. Have to check over here. Here is the mapper class. You are taking the record, and you are assigning one. I mean, pointing one. You are pointing one to as a value, and not assigning. Sorry, actually, You are giving the value of this each and every word of the record as a one, right? This is the perform of the mapping step, right? Of each and every splitted data set. Okay. Assume that there has two splitted sub data set. Okay. Okay. Now, after the mapping portion, it remains shuffling. After the mapping portion, shuffling is have to done. So, in shuffling stage, let me tell you one thing, that shuffling function, it is the second step in MapReduce algorithm. Shuffling function is also known as combine function. So I was showing you that one thing over here, that this is the combiner class. Okay, and you are writing this default, that is in some reducer dot class. Now, so this is the shuffle function. Shuffle function is also known as combine function. So it performs the following two sub steps. Shuffle steps has two sub steps. One is merging and another one is sorting, right? One is merging and another one is sorting. This merging step, this merging stage, step one and step two. Okay. Uh, step 1 and step 2 are there. The first step is splitted datasets one to single tuple and all splitted dataset to single dataset. So merging stage is divided into two steps, and the second portion is sorting. It will be clear to you when you will check this diagram. So after the mapping, what will happen? The merging step sub dataset will be this, because you know that we have the this is the merging stage, because all the rates, here is the rate, here is the rate, here is the rate, here is the rate. So four rate are there, right? So rate is equal to 1 1 1 1 4 1. Okay, here is the blue, here is the blue, blue, and three blue. Okay, so 1 1 1. Like this way, it will be merged. After mapping stem, it will be merged. And after merging step is divided into two steps. One is merging in each and every splitted dataset, and after that it merged the all dataset into single dataset. All the red, and here are the red. That means here three red, here four red. That means here is the seven red. 1 1 1 1 1 1. Here is the 4 1. Here the red is 3. Okay, so 7 1 is there. And after the merging step is completed, sorting step will be performed. Okay, what sorting step will be performed means for the sorting step, black, blue, green, orange, red, and white, right? This sorting step, what will happen? For this sorting step, you can check over here that these these are the keys, these are the list of values. These list of keys will be sort by lexicographical order. If they follow the dictionary, they have followed the dictionary order: black, blue, green, orange, red, white, right? Dictionary, uh, by dictionary order, it will be short, the keys will be short. This is the sorting step, and finally reduce step will come here. In reducing step, all the sorted keys, the list of values will be reduced by the reducer to 3651, and this reducer you have to write over here. You have written the program over here. This is the responsible to do this. Okay, so here you can get the result. I hope you can understand now the architectural workflow of the MapReduce job. So do you have any questions? You can ask me. Am I audible to you? Am I audible to you? Do you have any questions? You can ask me. If I okay, so if you want to actually, I wanted to show you a uh, small program on MapReduce, that will be the reduce site join. But if you allow me to show you, I will show you. Otherwise, I will in this session up to. So tell me your what do you want? Hi. So, if you want, to see another, I mean, to another last MapReduce program, so I can show you. So, if you are interested, then I can show you, because it has already been 3 hours, right? And I have skipped, really, I have skipped many questions which I wanted to show you, because first of all, I didn't know the proper settings of broadcasting in live YouTube video. That is the point number one. Okay. And many noises and disturbances you are getting, I can understand that. Okay. So still you are watching. That is a very big thing for me. But uh, okay. So I will end this session within uh, 5 minutes. Okay. So let okay, 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 okay. Uh, uh, okay. I told you that I will show you the MapReduce workflow given by the Yahoo. Okay. It is very very important for the interview purpose, because some interviewer, this is I think you have heard about the input split and record reader, right? These are the very common questions during the interview, and uh, very common questions. And partitioner, combiner, these are the very important question. So if you want to clear, if you want the clear concept on this topic, then you have to go through the deep dive into MapReduce by Yahoo's explanation. Okay. But I cannot show you today, because it is very I mean, it will take many more times to show you these things. Already 3 hours has been. So I will end this session within 5 minutes. Okay. Just showing you a diagram. Okay. That I will show you a MapReduce program where you can customize the reducer by, I mean, as per your requirement. You can customize the reducer number. You can customize the reducer number as per the requirement of your data. Okay. Yeah. Thank you, guys. And uh, let me don't worry, I will end this session within 5 minutes, okay, I will not go through details, because it will take many more times. Already I have skipped many more things. Okay, so so what is so I will show you a uh, uh, MapReduce program where you can customize the reducer. Okay, now uh, yeah, so you was asking me that who is responsible to provide the uh,
I mean to split the data, right? Here, who is responsible? So input split is responsible to split the data. This is very important question during for the interview, guys. If you want to looking for a Hadoop interview or Hadoop Spark developer interviews or CCA 175 preparations, then these are very important. Okay. These input please, what does input please? Input please, I will not go through this. Don't worry about that. Input please, I will actually input please, what does it plays the data, and record reader, what the record readers provides the byte offset key. Byte offset key means, the byte offset key, randomly generated byte offset key. Okay. In the mapper class, I was showing you the key is the value is the total record, and the key is was the what key was the byte offset key. So byte offset key and value, I mean key value provided by the record reader, is the record reader is responsible for that. Okay. Okay, fine. Now after the input split, you can check over here the input format is the default input format, and after that it leaves the data. After splitting the data, okay, according to the data, the key value is generated, and key value input, key value pairs generated over here, and after that mapper portion started. So before the mapper portion, this stories happens, guys. Did you know about this? This this stories happens. Okay, this is very important thing. When you are running any MapReduce program, or when you are submitting a MapReduce job, okay, so when you are running a MapReduce job, then actually what happens, this uh, uh, input format, and input data is splitted by the input format, and sorry, input split, and record reader provides the key value pairs, input key value pairs, and these input key value pairs goes to the mappers input. Okay, mappers input as a long writable and text. Text mean value is the text, key is a long writable key. That means the randomly generated byte offset key. Okay, and these intermediate key value pairs from the mappers. Okay, it comes into the partitioner over here. Before the shuffling process, there has another step, that is partitioner. Okay, internal steps, this is the internal procedure. Okay, uh, but if you ask me that if it happens for a normal MapReduce program, yes, it happens. Actually it happens at default. We do not have to write any shuffle, shuttling, or partitioner program inside our MapReduce program, right? We have to write only the mapper and reducer, right? But if you want to customize the reducer number, suppose you want 3 reducer, you want 4 reducer, then you have to write the partitioner class. You have to design the partitioner class. Okay. I will not go through in details. Don't worry, bro, because I promised you that I will end this session within 5 minutes. So, okay, get out from this, and let's go to the code portion. Okay, 1 second. This is the Eclipse IDE environment, guys. You can check over here that 1 second. Okay, this is the reduce site join. Do you have any questions? Oh, thanks, Balachandra Kasilangam says that I really appreciate it. Okay. Um, okay. So see over here that This is the program where we have written the Java program. We have designed the mapper class, reducer class. Okay, but check over here that we have written two mapper. One second. This is not the class. Yeah, yeah. This is the word count program, and this is the my partitioner class, right? Okay, so we have written the word count program over here. We have designed the word count program here, and you can check over here that we are tokenizer mapper. No need to repeat these things because in some reducer it is no need to repeat these things, right? But the story has been changed over the inside this driver class, because I told you what is my achievement, what is my purpose, what is my target, guys. My target is I will I want the output, as in as of what I mean. I want the output of a customized reducer. That means I want three more than three reducers. Okay, and suppose I have a suppose I have one second. Suppose I have this text file, this big dot text file. Okay, this is the this is my text file. This is a very big text, right? Very big text file, right? But I will not mm, take this text file because okay. Let me take this text file. No problem. No. Let me create a new text file. Just a second. Otherwise, okay. Uh, I have to write one word, two word, three word, four word. Okay. Okay. No, I'm not doing this. I'm not writing very big file. Just a simple small file that it will be easy to understand. Okay, it's a sample.txt that one word, two word, and three word. Let me copy this. One second. Sorry. Okay, I will not write very big in big. So this is the our sample.txt, right? I will move this file to our HDFS location. Just a second. Just a second.
Okay, guys, you can check over here that sample file contains these okay information. Now what I will do, I will describe this program. Here you can check over here that I want to partitioner class. This is the partitioner class. Okay, we have imported interpretable and text over here, and partitioner class, my partitioner class extends the partitioner. My partitioner is a user defined class. It is extending the org.apache.hadoop.mapreduce partitioner class. Partitioner class, what does partitioner class? Partitioner class, uh, it can uh, customize. You can customize, because we want to achieve the output as a customized reducer. So it takes the uh, text as a data, and the iterable as text is a key, and the iterable as a value, and it overrides the method get partition. And get partition is the method of this partitioner class, and this text as a key iterable as a value, and set num read task is the predefined here, where you can check these two lines we have added, guys. Only these two lines we have added. Everything is right, everything is same. In this program I will not describe anything, because everything is same. Mm, Here this is the word count program, guys. This is the word count program, but we have added these two lines only. Okay, so you can check over here that set partitioner class my is the my partitioner dot class, and the set num reducer task is the 4. That means we need, I mean, I want 4 reducer will be give us the output. Okay, 4 I need the 4 reducer, I want the 4 reducer. Okay, fine. And this is the set partitioner class, uh, where set partitioner class passes the my partitioner dot class, which is the this is the class under the partition package is the same, and my partitioner class we are passing this. Okay, now check over here that check over here, guys. We have get in this get partitioner method, we have written the string, s is equal to key dot to string, because uh, key is the that is the deer, beer, car, river. Those are the keys, right? And writable is means the ones, many number ones is the value. And set num read task is, we have set num in this set num read task, we have defined that only here, guys, four reducer, I want 4 reducers. Okay, okay, so here you can check over here that if is dot length method is compares to 1, that means in this here, if in this word, if any word is, length, word length is 1, then the the it will be output into the first reducer, return to 0. And if the length is 2, then if the length is 2, that means m, right? If the length is 2, if any word, then it will it will uh, return to 1, that means the second reducer. Return 0 means the first reducer, return 1 means the second reducer, return 2 means the third reducer. It designed like this way. Okay, and uh, more than 3 size of characters, if any are there, then it will return into the fourth reducer. Okay, so total 4 reducer I have uh, designed set num read tasks here.
You can check here. Okay. So do you have any questions, guys? Tell me. Is it clear over here? Now I will show you the output, and I will that will be the last topic. I will show you the just output. Okay. So guys, I have already generated a jar file over here by this exported, and you know about these things. I have exported this finish, and this I have exported this jar file over here. This is the jar file, right? This jar file contains the classes, partition package, and these are the classes. Sorry, these are the classes. One is the my partitioner class, and one is the WordCount class, because two Java file are there here, right? In under the partitioner package, right? That's why jar file contains these two classes. Okay, fine. So I have transferred this part jar using my WinSCP from my Windows operating system to Cloudera. Okay, and here it is the part jar, guys. This is the jar file. Okay, okay. So I have to run this. I have to submit this text file. They're already stored into the HDFS location. This is the file, sample file, uh, right? Let's see what happened. Do you have any questions over here? Okay, okay, fine. Now let me run this. Let me run this. Just a second. Here you can check that Hadoop jar. Here is the jar file name. Home training. This is the jar file name part.jar. Right? It's okay. One second. Check over here. Sorry, sorry. Okay. Okay. So Hadoop jar file location. This is the partition means of, oh sorry. Okay. Partition Hadoop jar file name. Partition means the package name. What count is the class name that you know that we have to write this like this way. The package name dot class name. Input path will be the user training. One second. I have copied the user training sample file is the input file, and output file will be there. Will be right here. User training. Uh, okay, S1. There is no directory name S1. No. Okay. Okay. So I'm running this user training. Okay. Yes, job has been submitted and job is running. You can check that a map portion has been done. Map 100%.
Yes, job has been done. Okay, output is given, and let's check. Go to the HDFS location, and yes, this is the guys. Yes, one. You can check over here. These are the guys, four reducer. Like, see, this is the first one, this is the second one, this is the third one, and this is the fourth one. So we did. I written in my code that who in which word character length is 1, it will return to the first reducer. Character length is 2. If the word character length is 2, it will put into the second reducer. If the character length is 3, it will put into the third reducer, and another anything more than 3 size, I mean more than 3 numbers of character size, it will put into the fourth reducer. So you can check over here. First one, I is 3. Why? Why? Check the, one second, sample. Yes, I has 3, right? Because one character is contains in I in the whole data set. Okay. Second is m is 3. It is a 2. I told I designed like this way, and this is will be the character of 3 length size. These are the yes, are, how, you, all are 3, right? And more than 3 will be here, but more than 3, that means the fine has the length of 4, hello is the length of 5, 3 is 3 numbers of word combined. One second, this is the, yes, fine, 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 and hello, hello, hello. More than 3 size, more than 3 number of character length. You understood this program? You got understood or not? Tell me. After that, I will end this session. Okay, so you have understood that. Okay, fine. Then this was the uh, it was the deep session, deep topics. I tried to uh, show you. Okay, fine. Thanks for your support and cooperation. Next sessions, it will depends on you guys. If you like, if you are interested, then I will tell you. Okay, let's come to the group. I will come to the group, and I will ask all of you. Then if you are interested, then I will always obviously arrange the next session by uh, discussing. I will discuss by my compatible date. I will fix a compatible date by discussing all of you. Okay, because you all of you are. I know most all of your employees are there. So Sunday is good, but yeah, I will discuss about that later. But still now, I am ending this session because it almost 4 hours. Okay, Okay, thank you guys, thank you so much for your support and cooperations. Bye.